Download this code from codegive.com, link in the description below. Sure. Let's dive into an advanced tutorial on combining retrieval-augmented generation, RAG, with text-to-SQL. This combination allows us to use natural language queries to generate SQL statements that can retrieve data from a database, while also leveraging external knowledge to enhance the accuracy and context of the generated queries. Overview of RAG. RAG is an approach that combines the capabilities of retrieval systems with generative models. It typically has two main components. One, retriever. This component retrieves relevant documents or pieces of information from a knowledge base or corpus based on a query. Two, generator. This component generates a response based on the retrieved documents and the original query. Overview of text-to-SQL. Text-to-SQL is a task that involves converting natural language queries into SQL queries that can be executed against a relational database. This is particularly useful for non-technical users who want to interact with databases without needing to know SQL. Combining RAG with text-to-SQL. By combining RAG with text-to-SQL, we can improve the accuracy and relevance of SQL queries generated from natural language input. The retriever can fetch relevant data and context from existing documents or a knowledge base, while the generator can create precise SQL queries based on this context. Tutorial steps. 1. Set up environment. 2. Define the data and schema. 3. Create a retriever. 4. Create a generator. 5. Integrate RAG with text-to-SQL. 6. Example usage. Step 1. Set up environment. You'll need to install several Python packages. You can use pip for this. Here's a sample installation command. Bash. Pip install transformers torch phase CPU pandas sklalkami. Step 2. Define the data and schema. For this example, let's assume we have a simple SQLite database with a table named employees. SQL. Create table employees. ID integer primary key. Name text not null. Position text not null. Salary integer not null. We can use the SQLite3 library in Python to interact with this database. Step 3. Create a retriever. We will create a simple retriever that fetches relevant documents based on the query. For simplicity, let's use a predefined list of documents. Python. From sklearn.feature_extraction.text import tfit vectorizer. From sklearn.metrics.pairwise import cosine_similarity. Sample documents. Documents equals. The employees are categorized by their positions and departments. Salaries vary based on the position held in the company. Employee records include name, position, and salary. Create tfidf vectorizer and fit on documents. Vectorizer equals tfit vectorizer. X equals vectorizer.fit_transform, documents. Def retrieve_documents, query. Query_vec equals vectorizer.transform, query. Similarities equals cosine_similarity, query_vec, x, dot flatten. Get the top two documents. Top_docs_indices equals similarities.argsort, -2::-1. Return documents I for I in top_docs_indices. Example retrieval. Query equals what information do we have about employees? Retrieved_docs equals retrieve_documents, query. Print, retrieved documents, retrieved_docs. Step 4, create a generator. Next, we will implement a simple generator that converts the retrieved documents and the user query into SQL. Python. Def generate_SQL, query, retrieved_docs. Simplified example, we will just return a basic SQL statement. If salary in query.lower, return select name, position, salary from employees where salary 50,000. If employees in query.lower, return select asterisk from employees. Else, return select asterisk from employees, default case. Example SQL generation. SQL_query equals generate_SQL, query, retrieved_docs. Print, generated SQL query, SQL_query. Step 5, integrate RAG with text-to-SQL. Now, we can integrate the retriever and generator together to form a complete pipeline. Python. Def rag_text_to_SQL, query. Step 1, retrieve relevant documents. Retrieved_docs equals retrieve_documents, query. Step 2, generate SQL based on the query and retrieved documents. SQL_query equals generate_SQL, query, retrieved_docs. Return SQL_query. Example usage. User_query equals list all employees with a salary greater than 50,000. Final_SQL_query equals rag_text_to_SQL, user_query. Print, final SQL query, final_SQL_query. Step 6, example usage. You can now run the provided code to see how the RAG approach can be used to convert natural language queries into SQL commands. Conclusion. In this tutorial, we combined RAG with a simple text-to-SQL approach. This example provides a basic framework that can be expanded and improved with more sophisticated retrievers, generators, and integration with actual databases. Further enhancements. 1. Use pre-trained models. Consider using Hugging Faces transformers for more powerful retrieval and generation. 2. Complex queries. Implement more complex query handling in the generator. 3. Interactive user interface. Build a web app to allow users to input queries and see results dynamically. Feel free to expand this tutorial based on your specific use cases and requirements.